Hello, YouTube. We're live. Somebody tell me you can see and hear me. I'm sorry for the fan noise in advance. There we go. That looks good. All right. I think DCD's out this week, so I won't expect a hello from them. I'll get started. Oh, you're seeing my desktop. Let me switch. All right. Hello, everyone. My name is Scott. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York City. And CircuitPython is a version of Python designed for little tiny computers called microcontrollers. What I've got on my desk this week to show off what that is here is a dev kit from Nordic. Let me unplug it. And what a microcontroller is this little tiny chip on this board here is called the NRF LM20. And what we do is, for Adafruit, I get CircuitPython working on little microcontrollers like this. And then we add support for all sorts of different features like BLE so that you can use it from your phone. And you can edit it to make it do what you want by using a code.py file. So this is Deep Dive. I do these pretty much every week unless I'm out or sick kids or whatever. It's an hour-long video of just showing you what I've been working on and then answering questions if folks have them, going on tangents about things that people are curious about. So if you have questions, feel free to drop them in the chat. I'm happy to answer them. I don't have a hard out, so I started late, so I'll just end a few minutes late as well. And yeah, I see a thumbs up from BP Tech Ops. Okay, so what I've been working on. Again, ask questions if you have them. But I did the GameBoy cart, and I did another revision after I got feedback from Lenore. So that's kind of like in process. It'll be here in a couple weeks, which is super exciting. And in the meantime, I was getting back to the hardware in the loop testing. I designed this board that I can also hold up with the idea that you can plug a board in here and kind of automatically talk to it to test things. And this is both useful for regression testing and for LLM kind of looping and being able to test things. So this is, a board I designed for that, and the microcontroller is here. It's an ESP32P4. And so this is meant to be kind of a whole host of these that host different chipsets to test on. So I've been working on that, and the LLM is starting to LM20 is also starting to come on my radar as a chip to get working on CircuitPython. So we'll do that too. What I wanted to show off is what I was working on with this, and then after that we can get to maybe dusting off the LM20 code, because they're now starting to become available, which is exciting. So this is a new Nordic chip that we'll talk about in a little bit. But first, let me show you what I got working, which I was pretty excited about. So the way that I want to make the hardware in the loop stuff work is, let me go to my desktop. So kind of the future of CircuitPython is Zephyr. So Zephyr is a real-time operating system that a lot of the different chip manufacturers put a lot of work into getting working. And it provides us this standard abstraction layer for basic stuff, digital pins and I2C and SPI and all that. That gives us an abstraction layer. So we can write CircuitPython to talk to Zephyr. And then the vendors do the part that takes Zephyr to their own chip. So it allows us to bring up a lot more different microcontrollers kind of like for free. And that's the LM20 is part of that. But when I was doing previous work with Zephyr, I set up some tests. And I don't know why something around my Git is making it really slow the first time I change into it. I'm not sure. Oh, it's not even right. It's part of it. I don't know what's making it so slow. Come on. Oh, it guessed. I think that's probably why I was trying to figure it out. You can see we're in hardware in the loop here. And so I can do make clean sim. And then make J32 sim. And it failed immediately. I'm not sure why. Let's try to make just the one board. Oh, you know what? I think it's because we are not in our virtual environment. There we go. So Zephyr builds rely on a Python tool that they've created called West. And so that's why it was not failing for me, is I didn't have the West tool available. So it's running two different test builds. We have a native sim build and a native NRF 5340 bsim. So bsim is this thing on top of the native simulator that does Bluetooth. And it does Bluetooth virtually, so you can run a test on your, like, in this case, Linux computer and make sure that everything's working. So it's doing the build for those two things, and then what we'll do is we'll run the test after that. And tests are a really good way to get this like hardware in the loop thing working even if you don't have hardware. So it's like the simulation here is like really trying to be quite faithful to the way the hardware works. But what I've been doing in this branch is trying to extend it so it actually, the same tests that we run in the simulator run on actual hardware as well. Let's see if we can make that happen. I don't know how long these builds take. I've not seen is anybody watching? I've not seen a single comment. I know we're like right in the middle of summer. YouTube says 9 people. So what I've been working on is the first kind of step to getting that cycle is, I see David's typing. The first step is flashing firmware. So I've been working on getting firmware flashing working over USB IP because that's how we access USB devices remotely. Hi, David. Thanks for letting me know. And thanks for watching. There we go. They're finishing. Another David. David Buchanan. Thank you. All right. So now that we have the simulators, we can do make test. And so these are different tests that we're running. So these are Bluetooth simulation tests. So connecting between two instances, advertising and scanning is running, being able to advertise, and then what happens when you do a Control-C. So those tests are running in the simulator here. And then if we would let that run and do a second one, let's source again, and let's see in my, I've been doing this thing. So on my desk, I have the hardware in the loop, I think that I showed. So this is a C61 here that I'm connected to over the network. And what I'm going to do is I have this test command, flash firmware CLI, and it is going to hopefully connect to this board, flash it. The LEDs flash while it's flashing. And it should put CircuitPython on this test board here. So it's using ESP tool over the network to flash this device. And the hope is that this would allow any sort of device to, any like host computer to use the same board for testing. It's a little bit slow. Oh, and it stopped. Wonder why it stopped. It got way further than it's been getting in the, anyway. So let's, I'll run it again and not hold it in case something that is there. And then, oh, this is why it stopped. Because there's actually tests here that are trying to do it too. This is a good example. So Yeah, it's trying. So what I was working on, I was thinking like, okay, ideally, how do you integrate this hardware in the loop testing? And it's like, well, I've gotten the Zephyr simulator stuff set up in a way that I like it. So what can I do? Well, I can use PyTest parameterization. So it's doing this I2C device probe test, and it worked on the native simulator, but it's not, it's actually trying to run it on the device itself. So I don't have it like saying like, no, you can't because somebody else is talking to me, basically. And so that's why our previous flash like also failed. This looks like it's still trying to talk to it, so maybe running it twice confused it. Or maybe we're still going. Yeah, we're still going and we're still trying. So we're passing on the native sim. We are actively trying to run all of these tests on the actual device as well, and that is failing. So the next thing kind of in hardware in the loop land for me to do is to pick a single test like blink, and let's just have this wait. And basically like making the hardware actual test stuff work in the same way that it works with the simulator. Yeah. So making PyTest apply to both real hardware and simulated hardware is the goal with this native sim stuff. Any questions about that? It was interesting because the other way that I could do it, and I think I showed this on Show and Tell, and we have to wait while this goes. It's testing all sorts of stuff in the simulator here. And I want to add a lot more as well. So I'll just Control C it. So the other cool thing about being able to use, this is all the error output. And it's basically saying like, things failed. Everybody tried to connect to it. Well, the test tried to connect to it while I was doing the other example here. But the other cool thing you can do is you could do sudo USB IP attach. And what this will do, actually I should show. So if I list serial by ID, I've currently only got one thing connected, and this is actually for the P4. But if I do the sudo USB IP attach, and then I give it, this is the MDNS name of the C61, and the particular device I want, I can, oh, I restarted. So I got to mod probe this. And now if I go back and list my serial devices, I see the USB to serial bridge. So this is why I was like, USB IP is the way to do this properly, is because I can both use the Linux kernel to do that USB IP bridge, or I can do it without Linux through my Python only stuff. But there was differences between it, and I had to figure out what those differences were. For example, one of the main things was the CP2102 Linux driver will, if a device says, hey, send this 32K of data, it actually chunks it into smaller chunks, which I didn't realize. And so there was a lot of that, like, make my Python CP2102 driver work the same way as my Linux kernel driver does. David's got some questions. Will some of this be in the GitHub pipeline, testing MRs, PRs on the simulator, some on the hardware in the loop? Or is it local only? So the tests are run in GitHub right now. Let me get, they are run on the simulator already. They are not run, the hardware stuff is not there. So the hardware stuff is not run automatically on PRs. But if we just pick a run here, this is a weblate run. And I think there's a separate Zephyr test. Zephyr, so we build every Zephyr board, including the native sim. But I think there's also a Windows Zephyr, but then test Zephyr. So if we look here, it took 32 minutes. It builds the simulators, and then if we look for the test run itself, oh my gosh. It took 15 minutes to set up Zephyr and only 9 minutes to actually run the tests. Yeah, I know what you mean. MR and PR, yeah. Merge request versus pull request. I know there's people that care. But yeah, so the native sim tests and the bsim tests are run on every change on GitHub. You can see this output looks the same. What I've been trying to do is I've been trying to get the hardware in the loop stuff where it's integrated into these tests, and so that's what I was doing, is like getting the ESP flashing, and okay, well, like what tests do I want to use and how do I trigger them? I like had LLM vibed up something where it would like had a separate run hardware's test command, and I was like, wait, you don't need that. And so I've kind of settled on this, like I really like the parameterization of the PyTest test to just say like, which board am I running it with? Which board ID am I running it with? Because we have board IDs for the native sim stuff as well. So, yeah, so there's your answer, is that the simulator stuff is running on GitHub every time. The hardware and the loop stuff is not hooked up yet. It's very, very early. Obviously, it doesn't pass. But the hope would be that, like, maybe eventually the hardware and stuff in the loop stuff is run on every commit. But we'll see. I think it takes a lot longer because, like, you saw how slow the flashing was. Yeah, so it's cool. I'm over USB IP, and now I could do the ESP tool. I was doing it make J. If I'm in espressif, I can make J. So this is the CP2102, and now I can flash it. And so this is still, and export. So it's still running over the network, but now the Linux kernel is doing that bridge between over the Linux kernel and my ESP IDF ESP P4 code is doing that bridge, is doing the bridge code. So we can see that, like, you can use a standard tool here once you've USB IP attached, which is pretty cool. It takes low-level USB packets and sends them over the network. So that they're, like, high enough that they're not timing sensitive, but they're low enough that they're below, like, the specific type of, like, device you're talking to. So yeah, that's how far I got with hardware in the loop. I gotta make sure it's all pushed. And I see Tyus typing, so I'm gonna hold in just a second. Yeah, and then I want to switch to talking back on Zephyr. So let me get ready for that. Figure out which of my 4 CircuitPython branches work trees I was in. I don't know why it takes forever. I should figure that out. Dual USB device, that's not the one I want. That is another idea I had, though, is I think it would be really cool to have a board that acts as a USB device twice. One so that you can control one computer while connecting to it from another. I think that would be really cool. Tyus says, have you been playing with Pico 2 or just ESP on the hardware loop boards and software? Also curious if you've had any hard to recover states over USB IP. I would say I've not really gotten to that point. So I haven't done any Pico stuff yet. And I would say that the next board that I'm going to really target is, I'm going to start focusing on the NRF 54 LM20. So that's probably the next thing I'm going to start playing around with on the hardware in the loop stuff. And I've actually, since I've been 3D printing, I've been experimenting with, so, can I rant? I rant. This is the development kit for the LM20 from Nordic. It's pretty cool. It does have like a number of buttons, and it has, here, I'll just switch to there, a number of buttons and some LEDs, but this is like one of the first boards where they stopped doing the Arduino footprint, which is like kind of what my board is designed to do, which is frustrating. And so in order to like connect a bunch of these pins, I've actually got to do an adapter, which is not a hard PCB to make. So I was starting to do the PCB design, and I used my 3D printer to print out all the holes so that I could test fit. I could test fit it before I actually do an order, and then like I could actually. So I was playing around with this number here is 0.15, figuring out how like the pin headers there will stay in, they won't fall out, but they're still a little wiggly. And I actually have another test print of like a smaller diameter to figure out if that like really gets on there. It's a bit of a, figure out how to get it. Yeah, it's a bit of a rabbit hole, how to get it on there. So I'm going to be balancing like more hardware in the loop stuff with also like, hey, we want to like actually make some products with this new chipset. And so I had Phil Lamore come to me and be like, hey, we want to try CircuitPython on the LM20 and the L15. These are two NRF 54s, which, have we talked about these two chips before on the stream? I don't know. I tend to talk about new chips on the stream. But I have the tabs open for these two, so let's just briefly cover them. So the NRF 52840 is a chip from Nordic that powers the Circuit Playground Bluefruit. We kind of skipped their 53s, the NRF 5340. Part of the reason for that was that at the time, like they were doing a whole big bet on Zephyr, and we weren't ready to do that. And they were trying to get people off their soft device at the time. They've like backpedaled on that a little bit since we made that decision, but that's part of the reason that you haven't seen like CircuitPython really on the NRF 5340. But then they came out with this newer series, the NRF 54s. And the L15s were one of the ones that were really available. There's also actually an NRF 54H20, but I think it's got a little delayed. I have like a dev kit for it, but I was actually surprised that it's like not even listed on their site. If you look for like Bluetooth low energy, their chips, they say that 54L series, they don't mention the H series at all, which I thought was kind of interesting. Because we were originally looking at the H20 because it had USB. The L's that they had announced, like these L15s, L10s, none of those have native USB, and so it was like not super interesting to us. But since then, they actually came out with this LM20. So the LM20 is like somewhere between what the H was and these L15s, where they're Cortex M33s, but they have a lot of RAM. So the LM20 has half a meg of RAM and 2 megs of NVM. So that it doesn't say flash because it's not actually flash. They're doing MRAM, if I remember right, MRAM or RRAM, some like new non-volatile technology that's not flash, which is kind of interesting because I think it doesn't have like, you don't have to erase a big block of it at a time or something. It's kind of interesting. And then the radio stuff. So all the radio stuff is the same. The LM20 is interesting because it has high-speed USB as well. So, and a lot of GPIOs, like I think enough to actually do a Metro, which would be cool. I don't think we have an NRF 52840 Metro. if I'm remembering right, because I don't think it has enough pins. Anyway, so like Phil and Lamore were like, hey, we want to try this and see how far we are, both on the L15 and the LM20. And I said, oh, like, just use Zephyr. Zephyr does this, Zephyr does this, Zephyr does this. And if you look at circuitpython.org/downloads, you will see that we have an L15 build. It was listed as an L05, which they say it's an L05 DK as well, because this is like the most featureful version. Whereas like you can get everything working on here and then like cut down RAM and flash and things like that and get the L05 version. But the LM20A was not something that I added here. So it was kind of hard to test out. So I dusted it off yesterday. I'd actually done this. And so let's find that. The other thing, so what I want to do is I want to get the board definition live kind of in CircuitPython so that it starts getting on the website. And we have 30 minutes to do that. So we'll do it here. You can see my branch is the NRF 54 LM20. And so let's take a look. I think we have more changes in here than we actually want. The other way to look at it is here. It is pushed to my, so I got a little, the challenge with LLMs is that it's really easy to start things and it's hard to finish them. It's all, and that's like even more true. So when I was back in Zephyrland, like one of the last things I was thinking of was like, you know, it kind of sucks to not be able to do UF2. UF2 drag and drop when you're like, oh, I want to try the next one. I want to try the next one. I want to try the next one. And the other thing about that is like, because you don't have a bootloader yet, you haven't taken that into account when you're placing CircuitPy. So like, you got to figure out where in the non-volatile memory you're going to put CircuitPy and kind of leave it there. Because if you don't pick a place, if you move it from build to build, people's code will disappear on them. And so I was like, we really have to think about the bootloader part of this. And so that's why that's where I ended up with the LM20. Was like, okay, like things are changing. I can't quite get there. But now we have these chips, and you can get them more easily. And so we want to make them first-class citizens in CircuitPython and start to make them fully featured. So what I was going to do is I was going to look at my branch and compare it to upstream active branches. I pushed it yesterday. I'm kind of surprised. Oh, no, these aren't my branches. These are Adafruit branches. My repo is a little weird because I forked MicroPython. So if I pull up my LM20 branch and contribute, it thinks I'm a fork of MicroPython. So I have to go in here and say, no, like I'm actually wanting to compare it to Adafruit. So this will show me all the things that I've changed. I'm not going to worry about that quite yet. So I have a lot of changed files, and there's some junk. This is all junk from LLMs. LVGL. Okay, so I've got lots of junk that I accidentally added, or the LLM added for me, that I want to remove. So how do I do that? Did you explain what the NRF 54 LM brings new compared to the Nordic MCUs we have? Okay, yeah, we could do that. So let's, instead of pulling up the L15, let's take a look at the NRF 52. It's weird that it doesn't show the, oh, am I missing? Oh, there it is. Scrolls within scrolls. So the one that we pretty much use everywhere is this NRF 52840. So Firefox has a way to do both, doesn't it? Anyway, we could flip through them. So the one that we have now, which we like generally call Bluefruit things, it's a 64 megahertz Cortex M4. So we're going from 64 megahertz to 128 megahertz. So our clock speed's doubling. I think this still has a float peripheral. The M33 is the ARM core in the RP2350. So that's like similar CPU. So we're getting a CPU boost, and then it's 2 megs flash internal and 512K RAM. So if we look at the 840, we basically doubled flash and RAM. Same 2.4 gigahertz. This talks about Bluetooth low energy mesh and thread and stuff. And I think that's all kind of like within this multi-protocol name. I know that, so the bit rate here is more channel sounding. Okay, so it does have channel sounding. So channel sounding is a Bluetooth 6 thing, BLE 6 thing, that is measuring distance between two devices, which I think is really cool. And then this is a little deceptive because it says it supports Wi-Fi, but that's actually with a companion IC. So I think it's unfair to say that it actually supports Wi-Fi. The chip itself does not support Wi-Fi. It's only BLE, and I think it's probably thread and Zigbee and Matter and all that stuff we would get on this chip itself, which is interesting too. That is true for the old one as well. USB 2.0, although that 2.0 on the 52840 is only full speed. I know for a fact that it's not high speed, so it's a little weird to say it. This high speed USB that the LM20 has is USB 2.0 as well, but it's high speed USB. It's like 480 megabits versus 12 megabits. And so it's a lot more, it is a lot faster. And then it is interesting, there's also this coprocessor. So there is actually a second core called, it's a RISC-V core, so it's not an ARM core. And it is kind of like free. So this puts us like somewhere around like what we could theoretically do with RP2350. It is a little weird in that, like, because it's RISC-V, like, maybe we decide, like, display I/O is going to be RISC-V compiled, and we'll run it on the second core. Like, we could start to, like, see ourselves farming it off. But unfortunately, because it's extra complicated because it's two different CPUs. It's not two copies of the same CPU. It's two different CPU architectures. Whereas, like, if we did multi-core with RP2350, we could like have the same code run on a different core, but we'd have the same copy of it, for example. Does that give you somewhat of an idea? Yeah, that's an interesting visualization. It shows the different packages as well. Yeah, so and then on top of that, we are not, our plan to support this is through Zephyr, not through Nordic. So if we're talking about CircuitPython specifically, it's actually a different ballgame. So the NRF 52s are supported kind of by directly talking to the vendor stuff using the Nordic port. But we kind of chose that, like, we're not going to do the 53s and 4s with the Nordic port. We're going to use Zephyr for the 53s and 54s. And the reason target a BLE API or Bluetooth API or some other API through Zephyr, we kind of like do that work once and then never have to do it ever again. And that's the selling point to a lot of these other vendors for just using Zephyr as well. Of like, Zephyr does a lot of the middle parts, like between the radio and the actual software. That's all shared and all open source through Zephyr. whether it's a Scilabs chip or a TI chip or an espressif chip, like that middle ground can be shared to all of them. And like by putting CircuitPython on top, we get like once BLAIO is complete, the theory is that it will work with regardless of what chip vendor at the bottom it is. So although there's not a whole lot new in terms of, I mean, it's twice as fast and twice the RAM, which is awesome in and of itself. But there's also stuff that, like, switching to Zephyr will also gain us as well. So, like, Nordic is one of the key players on Zephyr. And so when the Bluetooth people are thinking about adding things like channel sounding, like, Zephyr gets it first because the people that are working on the spec are actually, like, implementing it with Zephyr to know that it works. And so it's also really good for us to switch over there so that I think we're basically guaranteed that if we're built on modern Zephyr, we're up to date with modern Bluetooth specs. Zephyr also does like TCP/IP and Wi-Fi and stuff too. But yeah, for the this Nordic chip, that's why it's going to be super cool to have a product in the store that has Zephyr, CircuitPython built on Zephyr. And like Zephyr can get us some cool things with CircuitPython as well because it's a real-time operating system. So managing like, oh, like I need a new audio buffer and it's really important, but like this other thing that's running like your actual code, Python code is not as important. Like the real-time operating system will make managing that sort of stuff much easier. Okay, so what we need to do is we need to polish up this branch because it's full of a bunch of junk that we don't actually want. So the first thing I'm going to do is I'm going to rebase it all together. So my plan is, I'm going to type my password. But you can't see it. Hopefully I typed it right. I did. So what I'm going to do, my plan here is I'm going to rebase on top of the latest Adafruit main, and I'm going to squish it all together, and then I'm going to commit it, and then I will revert all of the files that I don't actually want in there, because this is what happens if you do like a git commit everything. You get a bunch of junk files, and my LLM at some point decided to make all these temporary files that somehow got in the commit, so we're going to clean it up. There is also some changes in here that is for UF2 support. So like changing the Zephyr, there's a bootloader called MCU boot that's commonly used for Zephyr, and I've got changes to that to add the UF2 drive, but I'm going to slim those and trim those out of this branch as well. So we've forked, and now we want to rebase on main. Do I want to rebase now? I'm going to make a new branch. Switch. So I'm going to just keep this state around. If I rebase now, rebase will change what the branch is pointing to. And I'm just going to say this is the 80 boot branch. So if I ever want to come back to doing the like UF2 boot stuff, I can go there. But I'm going to do... We're going to switch back, and now we're going to do the rebase. So I've like basically added a branch for me to like go back to. And we're just going to do fix ups, and because we want to get this in so that we can start making builds. And we're going to reword the commit. We're going to make it actually right. And then we'll use a merge tool. I think I'll probably use Sublime Merge to go through here and pick the parts that we want. So add more Nordic. I'm going to call this add more Nordic. NRF 4 board defs. I think this will actually end up with 3. The NRF 54 LM20 DK. the NRF 54L15 DK and the NRF 54L15 tag. This is a cool board. Let me show. Well, it's cool once we have BLE fully fledged. So this is a little tiny board that Nordic came out with for the L15, and it's basically an airtag. This is like, oh, so you want to make an airtag out of BLE6 and use our chip? Here's a dev board for that. And so what I had, so this is the normal L15 dev kit, and it has the similar headers and stuff. What they do is they have you flash it by just plugging the little tag board into the big board. But there's no UART, unfortunately. So like this one's not that interesting for CircuitPython until we have BLE workflow, again, dusted off and working in Zephyr, which will be super, super interesting. The other thing that's interesting, I mentioned channel sounding. So this NRF 54L15 tag actually has two antennas, and they're labeled, I think, there and there. And by having two antennas, like the software can do a better estimation of like how far away another channel sounding board is, or your phone too. I think channel sounding is particularly targeted at use as in car keys, to know like when you're at your car in a secure way. So it's like, it's not only range finding, but it's also like secure range finding to know like that it is what it is. Okay. So it's a little merge conflicty. So both modified. Okay, so this might be embed TLS. So the first thing to do is make fetch all submodules in case the modules got okay, for path lib LVGL. Okay, we're gonna have to get Sublime merge out here. But first I want to say, actually let's just do Sublime merge. And we are in CircuitPython left field, which is what we have open. And I know I'm too big, so let's make it stream sized. We can close this. Can I close the locations panel? Oh, that would be this. Okay, so we're during a rebase, and there's two changes here. One is MCU boot. Actually, I think we hit resolve. BSIM versus adding MCU boot. So let's get rid of the MCU boot stuff. We're going to do that later. And then what is different about this? I can't tell. Oh, this is a UF2 build, but it's here as well. So interesting. Let's take this one. Maybe I committed it already. Or maybe I had to fix it. We're not gonna do MCU boot, so let's take that out. Native sim, I2S capture. We do want that. These are the same, I think. So I think we're good with that one. Let's do the next one. Oh, yes, let's resolve this. Conflict. Feather. We want those ones. We want this. Huh. I thought I was more up to date on this branch than I was. You can see that we added Zephyr builds of the Pico stuff, so people, you can actually try CircuitPython on Zephyr using the Pico H20. So I think we don't want A to boot. We do want disabled modules. Let's do it this way. And remove this so that it's the same. Thinking about like how this is gonna get auto-gen again, I don't care. Resolve this. This says build extensions elf. I don't know why we remove the A to boot thing again. Maybe the flash stuff we don't actually need anymore. I wonder if I got rid of that. Disable modules. I think disable modules is to make space. Okay. Let's take a look here. Chosen code partition. Slot 0. I don't think we want that. I think this change was due to the boot stuff, which we're not going to have in it. Again, we're going to pick this. I think that's right. Oops. Resolve. Byte array. I don't know if I had NVM supported yet. Detect NVM partition. Okay. I think this left-hand side is what's checked in, so I'm going to bias that way. And I did I2S out later. I think that's right. Is there any boot-related stuff? Oh yeah, I thought when I rebased this, I had updated it, but it looks like I hadn't. So this is good. Okay, and then this we could discard. That's right. Doesn't know how to discard it. Okay. Module update lib embed TLS. Now we're clean, and we can do git rebase continue, and then we'll have to take a look at everything that we are. Okay, so we're rebased. If we look at our log, we can see here's our commit that we're working on, and here's what main is right now. And I realize I'm not looking at the YouTube chat. Ganondorf says, what OS is this? It looks like Mint or Ubuntu. This is, and sorry I missed this. This is KDE on Arch. This is KDE on Arch Linux. That's what I'm running. So this is console with a K. Okay, so now that we have that commit, what I like to do is now I'll look at merge, look at this commit and be like, oh my gosh, somehow all these LLM things got committed. So I will just say, do revert file, revert file, revert file, blah, 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 revert file. I'm like kind of frustrated that was in there. LVGL, we don't want to do that. Revert file. Unable to revert a deleted file. Okay, like, I think I I can probably get rm lib LVGL anyway. Let's see what git status shows. When I was talking about teaching git, changes to be committed, not staged. Okay, so these are all, it's kind of annoying. You can't just git rm ESP IDF activate because I deleted the files. I don't think Git is smart enough to do it without. Oh, it is. Sweet. Okay. So now those deletions are staged. And we've got some junk ones. It ports espressif as well. I don't know how they ended up there. I don't know what LLM decided that was the right thing to do and that it should be checked in, but we can do that. Ports. It's a little bit old. It's been a minute since I worked on this. So ESP IDF activate. It has some trouble figuring that out. There's one. And then there's also kconfig gen. All those. Okay, so now we've deleted those. Do we see anything else? There's some temp. And the CircuitPy one we don't want there either. Ports, Zephyr. CircuitPy. Okay. And now when we have these changes staged, we can git commit amend and change that. And oh, there's more. Temp. And do the same thing again. I'm trying to clean it up. I was like 150 files. It shouldn't be that many. And in fact, I see like all this partition stuff is part of the Adafruit stuff. So I think I'm just gonna delete it as well. I've got to like split it off and be like, doing that bootloader stuff later, which means that if you do try this, there will be a point where we do the bootloader and you'll have to like make sure you back up your files because it'll change where your files live. But yeah, so let's do git rm. Let's trim this down. Partitions. Remember, we're doing this on one branch. The branch I made before, the underscore Adafruit one, still exists with all these changes, so I can like not worry too much about it. And let's just take a look at. Okay, well let's just keep doing the amend. The bootloaderify thing I need to do too. Yeah, so these are the files that still exist in there. So let's take out all these MCU boots. So 103 files changed. These are all the new files. So that's part of the reason that we're seeing them here. So CP tools, bootloaderify. And it didn't get tests. And the sys build changes we probably don't want. This is so the danger of LLMs for me. Like there's all this stuff I want to do, and trying to do it all at once is not always the best thing to do. Has anybody else had that experience? Boards, MCU boot. Okay. We're trimming it down. don't know what these other added files are. Let's take a peek at this again. Didn't I just... Does it need to... I was thinking I should set up... Mine are good about not committing the scratch files, less so about telling me of their existence. Yeah, just like, oh, I haven't modded the thing yet. I don't know exactly what these conf and overlay things are. Chances are that I don't need them for what I want to do. These... Oh, that one in particular I want to undo. I do want to do these changes. The slot 0 stuff I want to revert, because that's bootloader related. Hex config build output bin. I might have to take a look at that. This is all boot. Yeah, let's revert these two as well. I can go down this rabbit hole another day. I take that back. These are USB changes I think I will. So let's do. What we can do is we should be able to revert lines. So I did some testing on this and I think I fixed that. Code partition. This is all partition stuff that I am going to revert. It's good writing the commit message to know like, oh, this is, so this Bluetooth stuff I do want to keep, because I was like, oh, I have the L15 in there, oh, but it doesn't have BLEIO, and it's like, oh, like I hadn't set it up to automatically enable. So this bootloader stuff. Autogen, I'm going to go through Adafruit. We're going to revert. Autogen, we will rerun. Revert this. No Bluetooth hardware on native SIM. That is a build change. I'm not sure about this external flash thing. I don't actually remember. So let's leave that for now, and we'll just revert the lines I want to revert. So as I'm doing this, in the working directory, you'll be able to see that like the revert lines or the revert files that I did are now kind of like staged. They should be staged. Maybe they're not staged. We can stage them and then git commit amend them again to do away with them. And we'll do a couple passes on this stuff to get it where we want it. The autogen stuff I don't care about because I'll just re-autogen it. Is this the one I reverted? Yes, because it didn't apply. Let's do this one, external flash, Ada boot. The external flashing, I don't think I need. This is new. That's okay. That's okay. Autogen. Turn off BLE. Slot 0 stuff gets reverted because we're waiting on this. I don't know. For the L15, I'm not sure. Oh, I think we want to revert it here too. The tag gets a UART. It picked some pins that I have to try. Enable the flash. 7002. I think I do want this. I'm gonna leave that there. I think I fixed some of the Wi-Fi stuff. I'm gonna revert this file though. We'll see. All this partition stuff, I'm gonna revert because it's related to the bootloader stuff. Any questions? I know I'm kind of in the weeds, but any questions before we wrap up? And I'll keep on doing this. My goal is to do it by the end of the day. Autogen, autogen, autogen. The autogen stuff is no longer done automatically. Or like it doesn't fail CI, so it's possible that it gets like stale. So I expect to have some autogen updates for other boards just because I'm gonna update it all. Ada boots. I'm still using Pi as my harness, yep. I don't know about the external flash. I've got to look and see how the external flash is used. Yeah, I'm doing mostly DeepSeek v4 Pro. I tried GLM 5.2 a little bit. I don't think Kimi K3 is included in any of the subscriptions at the moment. I'm gonna revert these. This actually, I enabled Bluetooth on this chip by doing some changes, which I'm like, that's good. I actually do want Bluetooth, like, as I'm working on Bluetooth, I want it on everything. But bootloader stuff, we're gonna wait. Yeah. I don't know about that. I don't know. I think I need to remove this NVM stuff. Or like there's a different version of NVM. I think there's a different version of NVM. So I'm gonna revert this. I think I might have added it separately. Compat to driver, detecting a different HCI. This is some Wi-Fi stuff that I think I can sneak in. I think this is bootloader. I think this is bootloader related. I think I actually want to revert this. I was like, wait, I have to enable this? Enable this? Sysbuild. Okay, so this gets reverted as well, because that's for bootloader. This is reverted as well. And then this thinks it's moving in. Okay, so we've got a bunch of stuff. Let's stage it all, and then commit it, and we'll wrap up. Stage all. Yeah, stage all. Okay. I just always remind myself, I've got it in another branch if I really need it back. Okay, so before we go, I'm going to do clean all within Zephyr. Did I source? I'll do it again. I'm going to clean all, and I'll get everything building, and then wrap up. All right. While that builds, we see how the 26 current Zephyr boards go. I'm going to wrap up. So thank you all for joining me for this deep dive here on Friday. I think DCD's plan is to watch it late and do time codes. So thank you to DCD in advance for doing that. Thank you all for watching live. Again, if you have questions, you're feel free to bug me on our Discord, which you can join by going to the URL adafru.it/discord. I'm there during the week, except when I'm off or have sick kids. If you want to support me, you can go to adafruit.com and purchase hardware there from Adafruit. We're going to have some cool stuff coming down the pike. And stay tuned for deep dives and all that. And I think I'm around next week, so I should be able to deep dive next week and hopefully show off some more. I think the plan for next week is getting back into BLE on the LM20, on the NRF 54s on Zephyr. So more Zephyr BLE is coming soon. And then the hardware in the loop will be kind of on the side as well. So yeah, thank you all. Have a great weekend. I'll do the window thing. I'll tell you, I missed it, but we have the Blue Angels in town. I'm in Seattle, and we have the Blue Angels, for those of you who don't know, are like 5 or 6 fighter jets as part of the Navy, and they fly an air show. And so they're here this weekend. They were practicing yesterday, and window cam would have seen them, and I was like, oh, I should have recorded. Let me go to window cam to show you. I should have recorded window cam because you could see like them flying in formation out here. I don't know how to turn it on remotely, but that would be kind of neat. Anyway, have a great weekend, everybody. I'll talk with you next week.